The next point, we should ensure whatever we see is clear.
That means work is being done. We can see that it is in opposite direction.
Good day, listeners, viewers at home. My name is Mr. Ibrahim Yunana, a teacher to teach you woodwork. I'm here again with another interesting topic, hand tools. Under hand tools, I will teach you measuring or geometrical hand tools. You remember our last period, our last lesson? We were able to talk about the different classification of hand tools to include measuring and geometrical tools, holding and supporting tools, marking out tools, cutting out tools. We also, cutting out tools are braiding cutting tools, shaving cutting tools. When we talk about braiding, we talk about saws. When we talk about shaving tools, we talk about planes. When we talk about paring tools, we talk about chisels, the different types of chisels, and so on. Today, I will take one of these groups of tools to talk about it, and the topic is geometrical or measuring or geometrical hand tools. Geometrical or measuring hand tools are tools used for taking and transferring measurements or distances on surfaces of wood and any other material. Measuring tools comprises of tools used for marking, setting out, and testing the various stages of work in the shop or industry. Now, my students, you know that there can never be any construction in the wood industry or in the workshop without measuring tools. Measuring tools are used for carrying out measurement, transferring them on the surfaces of the particular job you are carrying out so that you prepare them to exact required sizes. Now, follow me as we discuss about these measuring tools. The measuring tools include one, pencil. Every one of us know what a pencil is, and we all know what pencil is used for. Even in the primary, you can use pencil for drawing lines. You can use pencil even for writing. But in this specific area of discussion, pencil is used as a measuring tool. That is, if you have taken a measurement using one of the tools I will mention, then you transfer it on the surface and draw either a line or mark. That is the use of pencil for drawing lines on surfaces. Now the next one is the marking knife. The marking knife is what I have here. The marking knife is the blade is made of metal. Sometimes it comes with a wooden handle or a plastic handle. We said it's made of steel, fashioned to a point at one end and a sharp blade at the other end to form a cutting edge. Now the cutting edge, you can see, this is the blade. Now it is sharpened at one edge, beveled at one edge. The reason is to enable sharp mark or cut while you are creating mark on a surface. Okay? We said it is used for marking out lines where a vertical shoulder is to be cut with a saw or chisel. You can see this one is made of plastic. The one that is on the drawing on the board is made of wooden handle. And you can see one of the edge is beveled, okay, to a sharp point so that it will create a mark while transferring measurements on surfaces. The next one is the folding rule. The folding rule is there. It is a tool graduated about 5 meters long with intervals of 5 millimeters each. It is used for checking and setting out measurements on surfaces of wood. We have long surfaces. We call it folding. As you can see it on the board, it comes in folds, many folds. As you see it here, it can have about 10 folds. It depends on the distance you want to take. So you can take long distances on surfaces or transfer long distances on surfaces of wood. The next, retractable steel pocket rule. Why do we call it retractable? Because if you stretch it, it retracts. It retracts. We stretch it, it retracts. This is retracting. We call it retractable steel pocket rule. It is today the most valuable measuring tool in the shop. Why do we call it the most valuable tool? You see, all engineers, hardly would you see an engineer working without this tape. We call it tape, steel pocket rule. Why we call it steel pocket rule? You can put it in the pocket, you can hang it. It has a provision that you can hang it on your waist belt, on the belt, okay, to hook it, and you walk along with it, nobody knows. It is just like a knife for the butchers. But this one, it's used for taking measurements and transferring them on surfaces. I can determine the distance from here to here. Now, this measurement is, if I take this one, it will tell me what measurement I want on this one. This one gives me 1.5 feet or 8.2 meters. I want to transfer even less measurement on this one. I can take it and say I want to transfer 3.30 meters. I'll use it, okay, and measure here and then mark. Otherwise, if I want to transfer small measurements, I can take this one. Supposing I want to transfer, I can take this one, measure it on this one is a tape. I will talk about, a tri-square, but I will talk about it much later. But I can take the measurement on this one and then transfer it and mark it on a surface using the pencil. So it is called a retractable steel pocket rule, used for taking and transferring measurements on surfaces of wood and other materials, as you may think, in every aspect of engineering construction. The next is the straight edge. I do not have the physically straight edge here, but as the name implied, it is a straight piece of wood, either a piece of wood or made of metal or wood, that is used for testing surfaces. Supposing I use this one as a straight edge. Look at it on the drawing, and this serves as a surface. You put it on the surface of the wood, you place it, and then sight it with your eye. If there is a gap that is produced along the sighting of the job that you are producing, it means that that surface is not flat, it's not straight and flat. But as you put it, you roll it over and sight it. Where gaps are not produced, like I said, it is straight. Now you can sight it straight, diagonally, or across of surfaces to ensure that they are planed and kept flat and made what and kept flat. That is, you can see the demonstration. These lines, they signify either you do it diagonally or you do it across this way, or you do it whatever way you place it. The intention is to make sure that surfaces are tested flat and straight without holes, without gaps. Thank you. The next is winding stick. It's more or less like two of this, the winding stick. It is used for testing timber for flatness, like I said on the straight edge. One stick is placed across the end of each piece of wood to be tested. The top edges are then sighted. If they are not parallel, the bots are said to be in winding. If they are not parallel, the bots are said to be in winding. But if they are plain and tested flat, the bots are said to be out winding. Once we say out winding, it means they are plain perfect and there are no gaps or bends on the surfaces. That is the use of it. But how do we do that? Supposing we have this one, two of this one, you put one at the edge and put one at this side. You sight it just like you sighted the straight edge. You sight the levels, the tops. These are the tops. Supposing this one also, let me use this one. I put this one here and then sight. If you sight it and you understand there is one is higher than the other one, it means the surfaces are not flat. But if the levels are the same, it means the surfaces are, we'll call it out winding. They are perfectly plain and tested flat and straight. The drawing here has illustrated. That is what I have just illustrated. The next one is wing compasses. The wing compass is a pair of dividers made of steel. It has legs or wings being sharpened to points. They are fixed to a required radius by means of a set of screws. They are set to a required by means of a set of screws. They are used for setting out arcs of circles. For setting out arcs of circles. You all know divider that we use in our mathematics set and whatever. There are some other ones that are longer. We call them trammels in drawing. And they are used for drawing long arcs. You can see this one. The drawing illustrates. It has 2 points. One is fixed to base, and the other one is to draw very long, large arcs on surfaces of wood. Okay? This is the position that draws, and this one is fixed to point. Okay, that is the use of the wing compass. The next, we have calipers. Calipers are classified into two. We have inside and outside calipers. With me here, I have the inside and outside caliper. Now, this one is the outside caliper. Why do we call it an outside caliper? It is used for taking diameters of cylindrical objects, the external diameter of cylindrical objects. For example, if I want to take the diameter of this one, let me use the smaller one. If I want to take the diameter of this one, it has a screw. I will open it, and then if I open it, close it, and then take the diameter. Let me demonstrate this. I can determine the diameter of this. It will grip. The wings grip this one and hold it in position. Can you see it? Now, you pull it out, and then take a measuring instrument, either the tape or any graduating, and take the distance from one point or the other. That will be able to read the distance. Once you reach it, it will tell you what the diameter of this cylindrical object is. That is the use of the outside caliper. The use of outside caliper. Now the next is the inside caliper. You can understand. The inside is used for taking diameters of holes of cylindrical objects. How do we do it? Now, it has handles, it has wings. The wings are bent to the outside. But what do? They are used for taking the inside of the diameter of an object. If you put it, you on it, if you fix it, you adjust it. It opens and grips the internal walls of the cylinder, and then internal walls of the hole. And then by the time you bring it out, you use the tape, the measuring instrument, to take the measurement. You will be able to determine the measurement by the measuring instrument. This is the measurement. You determine the measurement by the measuring instrument. In conjunction, the measuring instrument now is what? Is the tape. And then the one that you determine the diameter is the internal caliper. That is the work. It is used when you are doing turning operation, especially when you are turning vases, trays, cups, and whatnot. Okay. Now the next is the squares. There are different types of squares. These include, one, tri-square, which everybody knows. Once you call a tri-square, everybody knows. A tri-square is this. It has this. It has the stock. It has the blade. Some of the stock are made of wood. Some are made of metal, of steel, and then a blade graduated. The essence of it is to be able to determine squareness. You can see the angle outside, external angles are square. The internal angles are square. So they are meant for determining squareness of surfaces, of joints. And then for drawing lines at right angle on surfaces. Supposing you want to cut a surface at right angle. That is the work of this one. You test for squareness. You use it for drawing lines, squareness. You use it for testing angles at 90 degrees. Once we say at right angle, angles at 90 degrees. So that is the use of this. The next is mitre square. The mitre square is this. Though I want to use this one to illustrate the two, please. The mitre square, it is graduated at an angle of 45. Once we call it a mitre square, it is an instrument, just like the tri-square, but it is the stock. The blade is fixed to the stock at an angle of 45 degrees. So it is used for marking lines at 45 degrees. Now look at this. This one this angle now is 45 degrees. So immediately you put it at this way, and you draw a line on this. This line is going to be at 45 degrees to any of the edges of the object that you are working upon. So it is used for mitering. Okay, it is used for mitering. Then we have the next. We have the combination square. Let me use this one, because this one we call it a combination. It carries the mitre and then the square H. The combination square, the blade slides on the stock. This is the stock. Now look at it. The blade slides. This is the blade. It slides on the what? The stock. This is the stock. The stock is also fixed at one side is fixed at 45 degrees, and then one side is fixed at 90 degrees. Okay? The blade slides on the stock, which has one face at 90 degrees and the other face at 45 degrees, like I have illustrated to the stock. It is used for squaring lines in rivets. It is used for squaring line in rivets. Rivets are not normal joints. They are joints that have shoulders. So I will not be able to explain until I have the real joint, the real rivet. But in short, it is used for measuring or squaring lines for rivets. That is the purpose of the multi-combination square. It is used also for, you can use it for mitering, to mark out miter jobs. The next, sliding bevel. The sliding bevel is used for duplicating angles and for setting out bevels and miters where the lines of the joint is other than 45 degrees. When I was talking about the mitre square strictly takes measurements at 45 degrees. But this one, it takes measurement less than 45 degrees. How? By the explanation, it also has the same parts. It has the same parts with the tri-square. It has the blades. This is the blades. It has the stock. This is the stock. It has the screw thumb, or the screw that is used for tightening the blades to the stock at any angle. Now, class, remember, I told you that the mitre square is for taking angles at 45 degrees only. But what if you have angles that are less than 45 degrees or slightly more than 45 degrees? You can still use this one because this one is adjustable. Look at it. It can close it to a lower angle, and then you can open it to an angle more than 45, even more than 90 degrees, class. Student. So please, watch out. The mitre square, the blades moves along the stock. It moves along what? The stock. And it is fixed in position or tightened in position by a screw. This is the screw. Once you tie the screw, the blade will not longer move. See, you tie the screw, the blade does not move. And so you can put it on the surface that you want. Put it on the surface that you want and mark. Create the mark that you want. If you want a lesser angle than 45 degrees, you can still mark it on the surface. That is the use of the mitre square. You can see on the drawing, the blade is held to the stock by a screw. My students, having gone through this, we have discussed quite a lot on these very particular tools. But let me also a little bit take you back so that we will be able to digest what we have discussed. Okay? Let's get back to where we started. Now, we have talked about measuring or geometrical tools. Why do we call it geometrical tools? Because all the tools, they are calibrated. They are calibrated, okay? And we said these tools, they are used for taking and transferring measurements on surfaces. You take measurements, Like we have, let me use this one, retractable steel pocket rule. You take it, okay, you take measurements, transfer it, mark before any other operation that is carried out. You mark or you transfer measurements so that you get exactly what you want when doing any construction or job, performing any job in the workshop. Okay, now like I said, we have first the pencil. Pencil, you think pencil is not a tool, it is, but it is used, it is one of the one also good tools that we use in the shop, okay, for drawing lines, for marking outlines, in conjunction with any other tool on surfaces of wood. Then we have the folding rule. I have told you, the folding rule is used for taking long distances, and it is used for taking and transferring long distances. It can take as much as 5 meters distance, but it is graduated in millimeter, intervals of 5 millimeters. The next is we have the calipers. I have told you we have the outside and the inside calipers. I showed you we have this one is the outside for external diameters, and this one is for taking diameters of holes on cylindrical surfaces. Okay. The next, I said we have squares. I mentioned different types of squares that we have. We have tri-square, we have sliding beveled, we have mitre square. All of them are used for taking, testing, and transferring various measurements when carrying out wood operations. My listeners at home, having discussed all about all this, I want to give you an assignment. And this assignment is, 1, state the classification of measuring or geometrical tools you know. State the classification of measuring or geometrical tools you know. Remember, we have 2 of these measuring or geometrical tools. We have the measuring, and then we have the gauges. And so, please, I want you to, on your own, sit down, discuss about, look into it, and then bring out good meanings and tell us what their classifications are. The next is differentiate between measuring and marking out tools with specific examples. Remember, we talked about marking out tools in our previous lesson. I want to see the ability you have to recall back what we discussed on measuring or marking out tools. So, okay, differentiate between measuring and marking out tools with specific examples. Number two, draw neatly the following tools. Identify their parts and state their specific uses. 1, inside and outside calipers. 2, sliding beveled. I repeat the assignment. I repeat number 2. Draw neatly the following tools, identify their parts and state their specific uses. 1, inside and outside calipers. 2, sliding beveled. My students will stop here to continue with other classes of tools when we meet during our next lesson. My name remains Mr. Ibrahim Yunana. Phone number or SMS number is 08028431113. I repeat again. My name is Mr. Yunana Ibrahim. Phone number 08028431113. Stay home, stay safe, keep learning.